Okay, we're going to review Chapter 3, starting with an example on skew lines. So what segment is skewed to segment AE? So here's AE, and if you look at your answer choices, the very first one, DC, segment DC, is definitely skew and is the correct answer. These two lines don't lie in the same plane and they're never going to intersect. Okay, which segment is parallel to GC? Let's find GC. GC is right here. So you can see it's an edge, a vertical edge going up and down. So the parallel lines are all going to be the vertical edges. So which answer is a vertical edge? It's not GF, it's not DC, it's not EF. It's got to be the very last answer, which is AE. There they are. Okay, which angles are corresponding? So let's look at our answer pairs. Angle 1 and angle 7 are vertical angles, not corresponding angles. How about 1 and 4? 1 and 4 are same side or consecutive exterior angles. So it's not 1 and 4. How about 16? Here's 16 and 14. Now that looks like the right answer. Let's make sure the last one, 15 and 11. 15 and 11 are opposite interior angles. So, yep, it's got to be that choice C. Which angles are alternate interior? Well, we saw an example the last time, alternate interior. Let's see if we can find them now. 11 and 7. These are formed by not the same transversal, so it's definitely not that. 10 and 7 are not alternate, they're consecutive, they're on the same side. Not that one. 16 and 12, so answer choice C. 16 and 12 look like alternate, but they're not interior, they're exterior. It's got to be the last choice. D, 15 and 11. And we're right. Which angles are consecutive interior? Again, let's check our answer choices. 7 and 6. So here's 7 and here's 6. Are they consecutive and are they interior? I think we found them on the first try. Okay, what are angle 8 and angle 4? What's their relationship? So here's 8 and here's 4. So here's the transversal shared by angles 8 and 4. They are external angles and they're on opposite sides. So they are alternate exterior angles, which is answer choice B. Okay, write an equation of a line parallel to y minus 3 equals x. To review, parallel lines have the same slope. They go in the same direction, they have to have the same slope. So any equation with a slope that's equal to 1, that's the coefficient on your x, we can get this to look like y equals x plus 3. Your coefficient m right here, m equals 1. So any line with a slope of 1, and we don't want it to be the same line, they're not parallel if they're the same line, so the y-intercept here, our line can't have a y-intercept of 3, so maybe something like y equals x would be a good example. Okay, in this example, line L is perpendicular to line M, and line M is parallel to line N. Therefore, so the scenario is we have two lines perpendicular and two lines parallel. Well, if M is perpendicular to L, N must also be perpendicular to L. Parallel lines are both perpendicular to the same line. Okay, for which of the following is the transitive property not true? So the transitive property, well, we've seen this in the previous example. Actually, we've seen if you have, let's say, line M perpendicular to line L. Let's see if I can label these. So here's line L and here's line M. If L is perpendicular to M and M is perpendicular to N, let's make those perpendicular. Does that mean that L is perpendicular to N? Well, as we've seen, actually it makes L and N parallel, not perpendicular. So transitive property not going to work for perpendicular lines. Okay, let's do some solving. The measure of angle 2 is 3x minus 8. So 3x minus 8 in the diagram. Measure of angle 6, 5x minus 33. Find the measure of angle 5. Knowing that M and N are parallel, we know that the measure of angle 2 equals the measure of angle 6 because they're corresponding angles. So 3x minus 8 equals 5x minus 33. 2x is equal to 25, which means x is 25 halves. There we go. Well, if x is 25 halves, and our goal is to solve for angle 5 here, angle 5 is supplementary to angle 6. They're a linear pair. So we know that the measure of angle 5 plus the measure of angle 6 has to equal 180. So angle 5 is equal to 180 minus the measure of angle 6. Well, the measure of angle 6, 5 times x. X is 25 halves minus 33. And that's going to get us an answer of 150.5. Okay, let's try a similar example. We know angle 2 is 4x minus 27. We know angle 8, 5x plus 36. And we're looking for angle 5. Again, we've got parallel lines, so that tells me the consecutive exterior angles, angle 2 and angle 8, are supplementary. So they're going to add up to 180. That means 4x minus 27, 5x plus 36 is 180. 9x plus 9 equals 180. 9x equals 171. So x is 19. Well, if x is 19, again, our goal is to solve for angle 5. Angle 5 is vertical. Angle 5 and angle 8 are vertical angles, so measurement of angle 5 equals the measurement of angle 8. And that is 5x, x is 19, plus 36, for a total of 131. Okay, if we know the measurement of angle 3, 112 degrees, angle 7's 78 degrees, are lines M and N parallel? Well, the positions of 7 and 3 are corresponding, so for M to be parallel to N, the measurement of angle 3 needs to be equal to the measurement of angle 7, and they're not. Clearly, they are not parallel lines. Okay, similar problem, only with algebraic degree measurements. Let's see if we can do this. Angle 2, we're going to say, is 5x minus 2. Angle 4, 8x minus 26 degrees. And angle 8, 4x plus 8. Is M parallel to N? Well, 2 and 4 are vertical, so 5x minus 2 needs to equal 8x minus 26. So they're vertical regardless of whether M and N are parallel. So we can solve for x here and see what x is equal to. Looks like x is equal to 8. X is 8. So if M and N are in fact parallel, that would mean the measurement of angle 2, which is vertical with angle 4, and angle 4 and angle 8, maybe we'll start there, angle 4 and angle 8 are corresponding angles, so those would have to be equal, their measurements. But if those are equal, since 2 and 4 are vertical, then the measurement of angle 2 has to also equal the measurement of angle 8. So if x is equal to 8, let's see if this holds. So measurement of angle 4, 8 times 8 minus 26, 4 times 8 plus 8. Eight times 8 minus 26 is 38. There we go. 4 times 8 plus 8 is 40. Not equal. Conclusion, not parallel. Okay, always, sometimes, or never true. Vertical angles are congruent. Always true for vertical angles. Alternate interior angles are congruent. That is sometimes true if the lines are parallel. Consecutive interior angles are congruent. Normally not true. Consecutive interior angles are supplementary, but sometimes if the lines are parallel and the transversal is perpendicular, your interior angles are both going to be right angles, they're supplements and congruent. So sometimes. Non-coplanar lines are parallel. No, non-coplanar lines are never parallel, they're always skew. Okay, we got a bunch of intersecting lines. Let's see if we can identify some angle relationships. So angle ECK, so here's ECK, and angle ACI is right here, ACI. Oh, that's not the right one. Back up. FAI, read the wrong example. FAI, here's FAI right here. Okay, what can we conclude about those? Well, they share this transversal right here. They're both on the exterior of these lines here, and they're on opposite sides, so that makes them opposite exterior angles, alternate exterior angles. Angle HCK, let's find that one. HCK, and ACI, that was the one I saw before, ACI right here. You can see they're formed by the same lines. So those are going to be vertical. KCJ and CAI are, well, I just gave it away, corresponding, but let's look at them. We'll see if we can see why. KCJ right here, KCJ, CAI is right here, and we're saying they're corresponding. You can see here's a transversal, and here are two lines. The transversal forms one side of each angle, and you can see they're corresponding on the same side of the transversal, on the same side of the two lines being cut by the transversal. So those are corresponding. Now how about last one, JCA? So JCA right here, and IAC right here. Well, they share a transversal, and these two lines being cut by that transversal. You can see they're on the same side of the transversal, and they're both on the interior, so that's going to make them consecutive interior angles. Okay, here's a proof. We've got two lines, A and B, are parallel, and then two other lines that are transversals to A and B, D and C, and those are also parallel. So given two sets of parallel lines, let's prove angle 1 is congruent to angle 3. We always start out with what's given. A is parallel to B, D is parallel to C. Now we know that angle 1 and angle 2 are congruent, and that's because they are alternate interior angles, because A is parallel to B and D is the transversal there. Okay, now we also know that angle 2 is congruent to angle 3 because angle D and C are parallel, or sorry, lines D and C are parallel, and if we look at B as the transversal, 2 and 3 are alternate exterior angles, and so those are congruent. Well, if 1's congruent to 2, 2's congruent to 3, we know that 1's congruent to 3 by the transitive property of congruence. Got it. Okay, last one. Given angle 2 and 3 are supplements, and angle 4 is congruent to angle 1, prove L is parallel to angle N. Okay, so angle 2, angle 3 are supplements, and then angle 4 is congruent to angle 1, and oops, that's our given statements. Okay, well, if angles 2 and 3 are supplements, that means line L is perpendicular to line M, and that's because the consecutive interior angle converse theorem. If consecutive interior angles are supplements, then you know the two lines are parallel. So L and M are parallel. Well, okay, if L and M are parallel, and we're told that angle 1 and angle 4 are congruent, then we know that M is parallel to N. M is parallel to N because angles 1 and 4 are alternate interior angles. Converse theorem. If alternate interior angles are congruent, that tells us that the lines are parallel. So M and N are parallel. Well, if L is parallel to M is parallel to N, L must be parallel to N by transitivity. And we've proved the top and bottom lines parallel.